Hey, hello everyone. Thank you for joining us today. I'm Ilyas Noula. I'm the Cleantech specialist at Veritech, and I'll be your host for today. As you all know, we're facing major issues in the cleantech sector in Lebanon and globally, and we need to start acting upon. We need to create a supportive community of experts, partners, NGOs, public and private sectors to help and support startups and entrepreneurs working in the cleantech sector to help them answer not only the local, but also the regional and the international needs in these sectors. The Cleantech Learning Series, as some of you already know, is organized by Veritech under the Cleanergy program, which is a program funded by the Embassy of the Kingdom of the Netherlands in Lebanon. The Cleanergy Accelerator aims at supporting ideas and startups working on solutions to the challenges that exist in the cleantech sector. So the teams that can join will have to tackle challenges in transportation, energy, water, waste, or agriculture. Through the program, Veritech will offer the selected startups the resources, the knowledge, the support, and the funding necessary to scale and grow. If you're interested, you can check additional information and eligibility criteria on Veritech's website, veritech.org. You will find the Cleanergy program under the section Programs. The deadline to apply for our second batch of the Cleanergy Accelerator is end of July. So if you think you have an innovative solution in the cleantech sector, I urge you to check the website and submit your application. Also note that we're having our Cleanergy Hackathon on the 13th of July, so from 13 till 17 of July. So if you're also interested in applying to the hackathon, the deadline to the application is 8 July. The winners of the hackathon will secure their spot in the Cleanergy Accelerator. So we encourage you to go and apply for the hackathon as well. As you know, the Cleantech Learning Series continues to host guest speakers discussing the challenges and the opportunities in the cleantech sector. Today, we're covering the water and wastewater sectors. I would like to thank our guest speakers in this webinar. We'll be hosting today Dr. Nadim Farajallah, Dr. Christina Jungfer, and Ziad Husami. You've seen in the promotion of the webinar that we should have had Susie Hwaik with us today from the Ministry of Energy and Water, but for some emergencies at the ministries, she had to cancel today, and we're having with us today Dr. Nadim Farajallah as a guest speaker. Thank you for joining us and for your continuous support, our speakers. And without any further delay, allow me to introduce our first speaker, Dr. Nadim. So Dr. Farajallah started out his graduate academic studies in irrigation engineering, attaining an MS from Utah State University, and then a PhD in environmental engineering from the University of Oklahoma in the US. His private sector work included stints in the USA with Stone Environmental, Montpellier, Vermont, and in Lebanon, first with Dar al-Handasa and then as a founder of the Land, Water, and Environment Department at the consulting firm SETS. Currently, he directs the Climate Change and the Environment Program at the American University of Beirut, Hassam Faris Institute for Public Policy and International Affairs. Dr. Nadim, it's always a pleasure having you with us. I leave you now to lead on your presentation.
Thank you, Ilyas. It's a pleasure being with you all. Susie would have made a fantastic speaker for you, and she would have really well contextualized Lebanon's current problems in the water sector. I will approach it in a slightly different manner. Due to the short notice I had, the presentation I'll make today is a hodgepodge of everything that I've put together. So please bear with me, and I'm open to any questions. How much time do I have, Ilyas?
Up to 15 minutes, Doctor.
Okay, great. I'll zip through some of the material that I have put together. Let me share my screen with you all and move on immediately so that we can have a better discussion. I think it's always better to discuss these things. Okay, major stressors for Lebanon and everywhere around the world is that there is a growing population requiring more water. Urban areas are growing, especially in Lebanon, horizontally rather than vertically, covering permeable surfaces so that water no longer percolates into the subsurface. In Lebanon, there is a growing natural scarcity, and as is in the most part of this region, climate change is adding to that. So these are our major stressors. Whenever you have a growing population and a growing economy, the demand for water always increases. And when you use water, you typically pollute it and you return it. Most of the water that we take in is returned as sewage. So the water we get, 85, 90% at times more, is returned as sewage. If that sewage is not treated and is dumped into water bodies, these water bodies are taken out as a source of water, and there becomes less and less water available for consumption. Hence, as the growing economy keeps growing and people grow more, there is a competition for an ever more scarce resource. This is where the major part of the problem occurs. In Lebanon, the interesting and difficult thing is that 70% of the population lives along the coast. And in 60 years, 65 years, this has nearly doubled. So it's phenomenal. 80% of the people live in urban settlements, and these are ever growing. The population right now is in excess of 6 million due to the influx of refugees. Originally, in around 2010, it was near 4.5 million. So you can see how population increased and the water availability, the per capita water availability dropped from being stress-free to being in scarcity. This is the chart that shows how population was sort of increasing and stabilizing, periodic increasing and stabilizing. Just before 2010, we were nearly 0.9, growing at 0.9% rate, which is very low. However, with the influx of the refugees, the population shot up. And this led to the drop in water availability to below the 500 Falcon Mark index, 500 meters cubed per person per year. And now we're lower than 450. And this keeps dropping. What are we seeing nowadays? If anyone tells you otherwise, they're wrong. Precipitation in Lebanon, whether along Beirut, the coast, or inland, has been constant for the past decades. In Beirut, for the data that we have at the American University of Beirut, since 1874 up until now, there is no perceptible decrease in precipitation. It's constant. There is natural variability, but it's constant. And you can see this in the Biqa as well. For the past 60 years or so, nearly 70 years, it's always been constant. Number of rainy days, again, has been constant. Temperature is the problem. Temperature, the minimum temperature has been increasing, as has been the maximum temperature. The minimum temperature is of concern because this is what keeps snow that falls on the mountains from melting quickly. As the minimum temperature increases, we often don't get snow and we get rain instead, and this reduces the ability to recharge groundwater, because as snow melts, it melts slowly, allows the soil to take in the water and direct it to subsurface. Drought incidents have been clustering and increasing. The last real major drought we had was in 2014, where only 370 millimeters of water fell on Lebanon. This is about what, 40% or less of what we usually get. And when we modeled drought, we found out that if the trends or if the projections that we have do become reality, instead of having one dry year every 6 to 10 years, we will get one normal year every 6 to 10 years. So that's an issue. These are givens. This is happening. Climate change is happening, and we need to keep that at the back of our mind. The way we look at water security, traditionally we were looking at water security in terms of if we have so many liters of water and we have so many people, how much can we provide? This is not water security. This is peanut accounting, and this is not good. Water security is much more than that. Water security is impacted by hydroclimatic factors and by anthropogenic factors, human factors. We need to make sure that water is productive, that supports economic growth, that supports human health. We need to make it safe for consumption and safe for the environment. And we need to make sure that every person has enough water to live healthily and productively. And when we look at the impacts of on the water sector, there is an impact on the governance, there is an impact on supply, on infrastructure, risks and hazards, economics, etc. All of these made us at the Isam Ferris Institute come up with 6 pillars of water security, and we call them household water security, which is how much water is made available to homes and also to farmers. And environmental water security, when we look at the water quality from the sources from which we take water and to which we send back our water. We look into hazards and risks. We look into the economic water security. How much are we making, or how much is the economy how well is the economy doing given the amount of money we pay into the water sector? How is our infrastructure doing? Because if we have an abundance of water at sources, but we don't have the storage capability, or we don't have the conveyance capability, we don't have, we might as well not have water. And then water governance. Do we have the right policies? Do we have the right regulations? Do we have the proper human capacity in the institutes to run them, to manage the water sector? Are we collecting the fees that we are charging? Are we charging fees fairly to have cost recovery? These are issues that are really kernel to making sure that Lebanon is water secure. And herein lies many opportunities. The key I want to focus on, especially through the clean tech sector, the clean tech approach, is energy in the water sector. Energy makes up 70 to 80% of, or electricity makes up 70 to 80% of the payment of the water establishments, or the cost for the water establishments, because 70 to 80% of electricity consumption is in pumping. We have pumping from the source to reservoirs. We have pumping from reservoirs to homes. We have pumping of sewage that is collected. Sometimes it's pumped, sometimes it's not, to wastewater treatment plants. And these themselves then either pump for reuse or pump into sea outfalls to discharge. This is where the energy is involved. So we have energy in water in pumping, we have energy in water treatment. Let me highlight this. We have energy in water treatment and pumping. We have energy in wastewater treatment, and these are, and in also in drying the sludge and transporting it. So energy is a huge, has a huge role to play. In Lebanon, the wastewater treatment facilities that we have are not operational mostly because they don't have enough energy. And energy And wastewater treatment facilities, keep in mind, can be a great source of water for reuse. They can be a great source of energy. When we digest sludge, we can produce methane that can be used to generate electricity or to power vehicles. We looked at Lebanon. The problem here is we have 12 hours used to and 15 hours of outage. Now it's even much more. The regional water establishments suffer from high electricity bills. Only the Beirut Mount Lebanon Water Establishment paid its electricity bills in full. And non-revenue water, that's the water that's lost in the networks and from people illegally hooking up to the network, is at times 50%. That means we are pumping water into the network, paying for fuel to pump water, and 50% of what's pumped is lost. So you are losing 50% of your money that goes into pumping. And keep in mind, 70 to 80% is pumping. We did a huge study that looked at 62 facilities, whether water or wastewater, and we did an audit. And what we found out that this is just a guide for you guys. And electric energy goes into motor losses, into pump losses, and the rest goes into energy, producing hydraulic energy. So typically, if we are doing well, we have about 88%, 90% production of energy. If we're not, it goes lower. The key takeaway of our studies, I'm going to go to two so that I'll leave time for discussion. There is no direct correlation between stations with high electricity bills and the performance of their pumps. We found out that in many areas, pumps are not working properly, but still the bill is reasonable. And in other areas, the pumps are working fantastically well, but the bill is high. The high energy cost is caused by inadequate pump. It's not always by inadequate pump. We need to look at the design of the network and how it is operated. In wastewater, the design is important. We need to look at how we're designing the facilities, what they do, whether they are activated sludge, whether they are bioreactors, the size. We found out, surprisingly, that smaller plants are more energy intensive than larger ones. So the scale needs to be adjusted, and we need to find a proper balance. And in both cases, in wastewater and water, the costs in operation and maintenance are critical to maintaining energy efficiency. So we need to be energy efficient in that sense. I will stop here and open it up for questions and discussion. Thank you.
Thank you, Dr. Nadeem, for this great presentation. It's good to see that there are like studies and that is being done in Lebanon, because like we always feel that we're lacking like the numbers and the analysis, not only in the water sector, like in many sectors in Lebanon. So hopefully like these studies can be translated or taken into consideration while setting the strategies and the policies.
Actually, they are.
Yeah.
Susie would have told you that this study that we did is feeding directly into the new water sector strategy, the revision of the water sector strategy. It's a major part of it. And they're looking at energy efficiency and transitioning into renewable energy in the water and wastewater sector through that new strategy. So yes, they are. And there's a lot of goodwill, especially in the new water, they're not so new, they're 3 years old. The directors general of the water establishments, they are very positive and they are avant-garde in their work, and they're trying very hard. So they're making things available for us to work with. However, the problem is now We are operating in an emergency mode, just trying to stay afloat, given the currency devaluation and our inability to purchase fuel, to purchase supplies and consumables and spare parts, etc. So, yeah.
That's great to hear, Doctor. For the audience, like any questions for Dr. Nadim? Okay, yeah, Ziad has a question, I believe.
Hi, Dr. Nadim. Actually, I recently read your report. Our startup is actually in decentralized wastewater treatment systems, nature-based solutions, and we are also trying to influence the water sector strategy. I realize there's a lot of emphasis on energy. So was that just an independent key performance indicator that was one of many when it comes to the design, or it's kind of a loaded question?
No. It's a great question. Look, when you design a wastewater treatment facility, typically what people think is, okay, I have this wastewater coming in, and you characterize it, and you understand what the major contaminants are, and you design your facility to treat that and discharge the water either up to a secondary treatment level or sometimes beyond. And this is typically where traditionally where people stop. And this is wrong, because in my opinion, what we really need to think about is, okay, I'm getting this wastewater in. Wastewater is a resource. It's not something to get rid of. We need to make sure that we treat it to a level that we can reuse it. And then we have to identify the reuse before we put in the design. So am I going to use it in agriculture? Am I going to recharge groundwater? Am I going to use it in cooling? What am I going to use it in? So that's your first question. The second question that you have to ask is, how much energy am I going to be consuming for treating this water? If it is too much, where can I compensate for this energy from? Energy is expensive. Can I put in photovoltaics? Maybe you can. You have the space for it. Maybe not. If I don't, what other alternative source of energy can I use? Can I use the sludge I'm producing? If you're going small scale, you're not producing enough sludge to digest, to power your facility. So you're going to need to be bringing in more, or shipping out your sludge to a treatment facility and a digestion facility. So
yeah,
if you think in advance of all of these, then your facility would be fantastic. It would reduce its carbon footprint, it would reduce its water footprint, and be a net positive rather than a net negative.
In terms of energy, I think you'd find it interesting. We ordered a windmill from Ohio, built by the Amish, and we use it to mechanically aerate our system, and then it switches on and off with a pump based on the availability of air. So maybe we can share that with you one day.
I would love to see that. Are you putting it in place? Have you installed it?
We've installed it under UNICEF Bilbao and in informal settlement. So
good. I saw Rebecca here online, so she will take us one day there, right, Rebecca? They cannot talk, can they?
Yeah, no, like they can just chat. Yeah, the attendees can just chat.
Oh, okay.
But I'm sure she'll take us.
I know. Yeah. Thanks, Rebecca.
Yeah. Yes.
Okay.
Any other questions for Dr. Nadim before ending this first section? Okay, so I guess that's it. If we got any questions for you, Dr. Nadim, we'll be happy to pass it to you.
Please.
Yeah.
And excuse me for leaving early. I've got an engagement that's heavy for me.
Yeah, no
okay.
Worries. Thank you so much, Dr. Nadim,
Thank you,
for
everyone.
being with us. Yeah.
Thank you.
We'll
Take care. Bye-bye.
Bye-bye.
Bye.
And for our next section today, allow me to welcome Dr. Christina Jungfer from Germany. Dr. Christina graduated her studies in biology, followed by a PhD in chemical engineering at KIT, with focus on technical biology. Since 2012, she works at Dekema as project manager in several water-related European and national funded projects. The focus of her current work is the integrated industrial water management, as well as the reuse of water in industry, also at the interface to other sectors, municipalities, agriculture. Dr. Christina, thank you again for joining us today. Looking forward for your presentation.
Thank you very much, Elias, and thank you for inviting me for this interesting workshop and to present my work here. And I will now share my screen. Hopefully it will work. So, and then the presentation mode. So hopefully you can see it. Just let me know.
Yes, we can see it.
Okay,
Yep.
great. So, yes, thank you very much for being here. And I would like to present some insights about a German funding measure called WAVE. And this funding measure is sponsored by the Federal Ministry of Education and Research here in Germany. And WAVE is about technologies and concepts to increase water availability by water reuse and desalination. And what I've heard from the speaker before, I think this could be also very interesting for you. Okay, before I start, I would like to show you what Dekema is doing, and then I will go show you a short overview or will go a bit deeper into the funding measure. So Dekema is the expert network for chemical engineering and biotechnology in Germany. And sorry. And we are a non-profit professional society and represents these fields of bioeconomy and chemistry in science, industry, politics, and the general public. And Dekema promotes scientific and technical exchange among experts from different disciplines, organizations, and also generations. And we consolidate the knowledge of over 5,800 members, involved and sustaining members. And as you can see here on this slide, we are working on 7 different focal topics. Beside the bioeconomy and chemistry, topics are also the pharmaceuticals, medical technology, but then interesting for here maybe the resources, the energy and climate, and the water management. And what we are doing in the water management, where I'm working together with a group of Thomas Track, we are looking for focus on the optimization of water use in industrial processes, the reduction of dependency of freshwater resources are for industry very important, but also for other sectors. Other topics are cost of efficiency in wastewater treatment, the digitization of industrial water management, and really focus is that we would like to boost innovations at the interface between on the one hand side the process industry and on the other hand side the water management, but also on the interface to other sectors like the municipalities and also agriculture use for the water. So and as we heard before concerning water, we are facing global water challenges. Over the last years, we see the development of the climate change on the one hand side here. On the left side, you can see that the climate development in Germany. We have also an increase in temperature and climate change. And on the other hand side, there are growing water demand worldwide. What you can see here, what we are expected in 2050, this shows this graph. So water is needed from from different users and sectors. Drinking water has the highest priority for human, of course, but also water for agricultural production is of importance. But the industry needs also water in large quantities and also in the right quality for the production, for cooling, for everything. So achieving an increase in water availability is not only crucial for classic arid regions, maybe like you're you are an arid region, but also regions like Germany for densely populated urban industrial areas. And yeah, so global increasing water stress is up to date. And beside this climate events and the climate change, usage competition is a big challenge when it comes to regional water stress. And in the figure on the right side, you see water stress regions in Europe and also in Germany that is known as a water-rich country. And also you see here other Denmark and other countries that are rich of water, especially in the spring and summer months. Yeah, we saw in the last year really a problem with the water, and in some regions usage competition is already yet a big problem. And this will also increase in the future. So there is an increasing demand for innovative technologies and concepts for water reuse and desalination for Germany and yes, abroad. And the Federal Ministry of Education and Research has recognized these challenges at an early stage and started already in 2016 the funding measure WAVE. And here you can see that it's is of importance for Germany. So the Federal Ministry of Education and Research has funded this funding measure with a total funding volume of 32 million euros. We had 13 joint research projects with in total more than 80 partners that were funded with high involvement of SMEs and industry. And WAVE, this funding measure, was complemented by a scientific support action that is coordinated by Dekema, by us. And yeah, the projects were running from 2016 to 2020. And the project sites that you can see here were located in Germany and abroad. We had 2 project sites in Vietnam and 1 in Namibia. The main topics in this funding measure, we had the 3 topics: water reuse by utilizing treated municipal wastewater, then the circularity in industrial water, reuse of industrial water, and the desalination of ground and surface water. And we had, beside these 3 thematic areas, we had also cross-cutting topics that were interesting for all thematic areas and for different projects. This was the risk management. That is crucial when practicing water reuse. We've heard this before. Also crucial is the topic salt and residuals, including the handling of management of concentrates. This is a very important topic, especially for the industry, but yeah, also for other sectors. And of course, the topic technologies and processes in terms of assessment of water reuse technologies and processes, or also defining key performance indicators for these approaches. And yeah, the aim of the funding measure was, okay, to increase water availability, to decrease the dependency of freshwater resources for different sectors, and therefore to reduce usage conflicts and contribute to the sustainable development. And what the projects, 13 projects has achieved these aims, and I will show you a bit later some more details. And our strategy was to not only to develop innovative technologies and management concepts, also to demonstrate in Germany and also abroad, and have then references and be prepared for the transfer into the practice. So, and that these technologies, concepts can also be implemented successfully. Oops, sorry. So here you can see an overview of the solutions that were developed within WAVE. So we had different solution approaches, for example, increasing water availability by using treated municipal wastewater and develop flexible production chains to produce different qualities of water that can be used for different sectors, for different purposes. So I will show you a bit later. And also for groundwater recharge. This was also a topic, and here multi-barrier processes, smart systems were developed. And for the reuse, for agricultural reuse, we used the treated municipal wastewater. So we developed high-tech and low-tech technologies. So for example, hydroponic systems, this is a high-tech technology, and and for reusing and make good use of the reused water, or maybe also with ponds, cleaning the water within ponds, very low-tech technology. Also for coastal resources means salty waters, so efficient membranes were developed, modular concepts were created, and for the industrial solutions, integrated solutions, we really wanted to find solutions for concentrates, what to do with the concentrates, how to manage water very good in industrial parks and use the water better, reuse it better, and find solutions for different industrial sectors: chemistry, steel, automotive, mining, and oil and gas and ceramic. Was developed. I will show a bit more later. And we had developed different technologies and concepts, treatment concepts and combination. Monitoring was very important. The assessment with the KPIs, the assessment tools, risk management and concentrates. And the application was really for the different sectors, reuse in municipalities, industry, agriculture. And we showed everything also in reference projects. So I would like to pick some projects here out and show you very short some insights. So for the water reuse by utilizing treated municipal wastewater, we had 4 different projects, and I will show you the multi-reuse project or multi-reuse project. So this project developed flexible production chains. So they produced different water qualities and water quantities with this production chain to with treated municipal wastewater for variable application. And so you can see this here a bit more. So usually treated wastewater is being fed into the rivers. The focus on the research project was to reduce the water instead. And so that they reuse with flexible production chains, different qualities to reuse it in different sectors like the industry, the agriculture, the aquifer recharge, or also for municipalities. So new technologies and methodologies for reuse of treated wastewater were developed and tested in a pilot plant in north of Germany, and reliable procedures for the quality control of water were also developed, an evaluation tool and concept to market the results of the projects were also developed. And what we achieved really is that with these results, you can achieve about 1 million cubic meter per year freshwater savings. Okay, going to the next, the reuse of industrial water. We had a lot of projects developing solutions in different sectors, and I brought with me, this was wrong. I brought with me the example from the steel industry. So they were looking for extended cooling water circuits. So water is an essential element for the process and product cooling in the steel industry. And due to the complex chemical composition of cooling water caused by the use of cooling water treatment chemicals or the introduction of solids, oils, greases, whatever, no chemical free and economic treatment process has yet been established on the market. And the aim of the project was to increase efficiency of cooling water use, to reduce the amount of blowdown water by 50%, and thus the involvement of fresh water. And so in this project, different innovative technologies were developed for desalination, for example, the capacitive deionization that you can see here, or fouling resistant coated reverse osmosis membranes. And they look also for the concentrates, how to manage them. And they had the high pressure reverse osmosis for concentrates removal or the evaporation also. And these process concepts in combination with were developed in combination with a simulation tool to determine the optimal process integration, as well as the measurement and control concept for demand-based dosing of water treatment chemicals. So this was an example from the steel industry. And with this solutions, they could recover water 80 to 95% for internal water reuse in cooling circuits. Yes, another example is from the oil, gas, and ceramic industry. There are very complex process and wastewaters, and here effective treatment was developed with ceramic nanofiltration membranes. So you can see here the flotation filtration treatment. It is with a microflotation and ceramic microfiltration as the pre-treatment, and then the nanofiltration for the treatment from ceramic membranes. Okay, and so my last example, I hope I'm not too late right now. I think I have too much today. For cross-sectoral issues, solutions for cross-sectoral issues, we had one very interesting project, and they were looking for the concentrates arising from industrial water reuse. And in addition to the conventional water reuse, this project includes a separate concentrate treatment to separate and to recycle these salts. And they had a lot of innovative technologies. I don't have them with me today, but yeah, we can talk about that later. Yes. Okay, so yeah, perspectives for solution providers and water users. I think this is very, the WAVE funding measure was very good perspectives for the water reuse. So we saw a lot of saving fresh water, reduce wastewater discharge, reduce resource use or energy use, and be more cost effective. And what was also very important is the transferability of these technological and conceptual solutions to comparable sites, not only in Germany, of course, but also international abroad. So this is very it's very important for the German technology provider to really go out and show their results there and their solutions. When you are interested and you want to have more information, so in 2020 we published a WAVE special issue on the IWA journal, Water Reuse and desalination. This is free. You can download it from the internet. And so we have about 20 articles in it with a lot of solutions and very interesting insights out of WAVE. Then this is very new and unfortunately right now only in German, but we are really working. So we have developed an atlas of water innovation where you can find all single solutions and process and whatever what we are developed within the WAVE project. And we have also a homepage. This is also in German right now, but I promise it will be in English very, very soon. So we are working on that. And so I talked today about this funding measure WAVE, and the Federal Ministry of Education and Research, they decided to start a new funding measure. This started in 2021 and will run until 2024. There are very similar topics to the first funding measure. It's again about water technologies and reuse, and so we are really looking forward to this new projects and to the solutions. And Dekema will again, being part of this funding measure. So then I hope I was not too long, my presentation. I thank you very much for your attention. And here are my colleagues with me. So if you have questions, just let me know. Thank you.
Thank you so much, Christina, for the presentation. Interesting to learn about the different projects that you're involved in and the new technologies that is being brought to the table. So now, if you have any questions for Christina, please post them on the chat or in the Q&A window in this webinar. We already have like a couple of questions. Was the desalination for wastewater treatment or to supply potable water?
Both. So so in Germany we will not desalinate for potable water, but I think for other countries would be very interesting. But in Germany we wouldn't do that, but we can do that with the technologies that were developed. Mm-hmm.
Okay, and
can I also see the questions? I don't know.
Yeah, and the chat window, like another question from Ziad. So I've never heard of ceramic filtration. Does that also act as a biofilm carrier?
That's a good question, and I'm not so deep in all these technical things, but I don't know if Ziad know a bit more about that.
I'll send you an email. I don't mean to put you on the spot.
Okay.
But since you have interesting technology, I'll connect with you separately.
Okay.
Okay. Any other questions for Christina? Okay. So I believe, Christina, we will also be passing any questions that we're going to receive to you, and I'm sure that you'll be more than happy to answer these. Thank you again for joining us, and looking forward for more collaboration in the future.
Yes.
We're definitely going to stay in touch, and
great. Thank you.
hopefully you enjoyed it with us today. And now for our last but not least speaker, Ziad Hossami. So let's take a quick intro about Ziad. So Ziad is the co-founder and CEO of Mruna. Mruna specializes in solutions and services which promote sustainability and urban resilience. He has international experience in urban planning and sustainable construction within the Middle East and the US. He has held a variety of roles in both the private and public sectors, which advanced a holistic understanding of the spectrum of stakeholders and skills involved in the urban development process. Ziad, thank you again for joining us today, and we'll leave you to your session. I don't know if you have something to share, or you're gonna go.
Sure.
Yeah.
So I think also to add to the intro, people probably don't know, is I was also the Veritech program. So I'll just take it from here. So I think Ilyas invited me just to discuss the journey into the entrepreneurship field. And I think I'll just start with a small slide, a couple of small slides, and we can discuss some things. You guys can see my slides. Can you give me a thumbs up, Christina? Okay, perfect. So
Yes.
has anybody heard of the Glauca maxima? And because nobody can respond, I'm going to respond and say no. So the Glauca maxima is actually the sewer system which is under Rome. And Pliny the Elder called it Rome's greatest architectural achievement. And that was 1,000 years after it was built. And he said that about 1,000 years ago. So it's about 2,000 years old. So until today, mostly, maybe until recently, the way we think about sewage infrastructure really hasn't changed that much. It's you want to get it underground in a pipe and as quickly as possible outside the city and make it someone else's problem. So in places like Lebanon, that causes some issues. Here we'll build some, centralized sewage treatment stations, which is why I was having a discussion with Mr. Nadeem, that are built by donors, but are never connected to anything because 80% of your cost is in building the actual sewer network. So previously, when I was a consultant at ACOM, it's a design consulting firm, and it's the biggest in the world. And we had a developer call us and to make a sustainable villa community. And they really wanted us to design a sustainable villa. But when we started looking at it, we had architects, we had infrastructure guys, the issue starts way before looking at the actual plot level. It starts with the infrastructure. And the way you design cities is around the infrastructure, and it starts with that. If you really want to be sustainable, and especially in a city like the UAE, where they're desalinating water, Christina knows probably very well, and then reusing, and then using that water for irrigation. Any sort of savings you have in water will increase your sustainability tremendously. For example, a study that we did was that, if you have about 300 houses, you have about 500,000 tons of carbon that you could save just by reusing water. But what happened was, this is about 5 years ago, not 4 years ago, that the project came, we made a pitch, and the idea of changing infrastructure was very difficult. One, you have regulatory requirements. Two, it's a massive company where every day you are responsible for clocking in where you put your hours. And it was, I'm not going to say this about all big companies, but a lot of them will talk about innovation, but innovation is actually takes a lot of hard work. It takes a lot of time. It takes a lot of investments. And it takes a lot of risk. And not anybody really in the company was really inclined to discuss, wastewater treatment and solutions around that. So, this was part of a presentation I had put together. And, at the time I didn't get a lot of support. I had attended some things in Abu Dhabi on wastewater treatment solution providers. And there happened to be a guy who was in Sweden, who, when I was in London, at my brother's wedding, I decided to go visit him. And we started talking about nature-based solutions and how to decentralize infrastructure. So just, to fast forward on the story is, it's a typical story. It starts out as a trickle, but it eventually turned to, you know, putting in a couple of projects that failed spectacularly in Lebanon, and in the industrial area, which is very different than domestic. And then coming back now to where we are today, where we are in a project with UNICEF and looking to scale. But I don't want to get into pitch mode and start discussing my solution and my project. But I will just leave you guys with something. When thinking about submitting to Veritech, Veritech help us to go from, you know, from the guys that I met on the journey, from being just a ragtag group of guys, and really thinking of ourselves as a company and try to put processes and milestones and basic achievements that that will get us to where we want to go. And you know, especially if you come from a technical background, there's some things from the business world that you sometimes scoffed at, and whatever, marketing or, you know, business. That's not really, you know, a field, is it? You learn the importance and value of it very quickly, and you can get some things from Veritech from that. But you know, one achievement that we won aside from Veritech was we were the global winners of the G20 Infrastructure Challenge, and they were looking for ideas that would influence tomorrow's infrastructure. And in our competition, we were up against people that were just discussing AI, and we were talking about machine learning and all these high-tech things. And they were coming from Singapore, London, you name it, Australia. And our solution was basically, it was quite basic. We're talking about a nature-based solution, which is easy to operate and maintain and install, and newly accessible technologies, IoT, for example, to make it accessible remotely, to manage it from a long distance. And these are all things that we learned on the way. And we won. So I think, you know, you don't have to have these, you know, massively complex innovations, but, you know, there's going to be things out there and opportunities that even, you know, the biggest players, the biggest companies have just ignored, because they really take a lot of energy, they take a lot of thought and innovation to get them there. And I think you will find them. And if you believe in it, you know, just keep going. That sounds like a cliche now, but I think a key takeaway is that you don't think that it has to be extremely complex or innovative. And sometimes there's things more about the process and how you take it and how you validate who the market is, and you can learn that with Veritech. So I think I will leave it at that. And if anyone has any questions, and anyway, we're a little over time. So thank you, Elias.
Thank you, Ziad, for this interesting, like I would call it the testimony. So we've enjoyed, I believe, the ride together, and I believe that you're on the right track to succeed. You have already lots of competitions proving that you have a good product in your hand. And thank you for joining us.
Yeah, and we got our factory up and running and lots of business going, and that was directly with the help and funding and technical support of Veritech.
Thank you, Zia.
So,
great.
Still
Yeah.
us to visit, eh?
Great to hear that. So for the audience now, so if you have any questions for Ziad, if you have like, if you'd like to learn more about some maybe challenges that you're facing in your entrepreneurship journey, or that you are afraid of facing, Ziad is like, he has the answers like hands-on. So it's not like some theoretical answers. So if you would like to ask him any questions, this is the time for that. Okay, so If we have no questions, I would say I would thank again our speakers for today, Christina and Ziad. Ziad has already put his email in the chat if you want to reach out to him. He's usually very helpful, even if it's not in his domain. So he can pass his connections to everyone then. Thank you again. And before ending, thank you, Christina, for the email as well. Just before closing, please keep in mind that the deadline to apply for the second batch of the Cleanergy Accelerator is end of July. So if you think you have an innovative solution in the clean tech sector, I urge you to check the website and submit your application. Also keep in mind that we're doing our Cleanergy Hackathon, which is taking place on July 13. So you can also check it out on our website and apply before 8 July for you to get the chance to join the hackathon and be among the winners who can directly qualify to the Cleanergy program. Thank you all, and see you soon, and stay safe.
Thank you, Elias. Thank you, Christina. Thank you all for listening.
Thank you.